Good morning. I'm Jules Van Tyne. I'm a third generation Boulder County farmer. This is my 42nd year of farming. Farmed in my partnership with my dad for about 15 years before I started on my own. I grow mainly corn and wheat, alfalfa, some pinto beans, sugar beets, a few pumpkins. We've really adopted to strip till a lot in the last 10 years, which is so efficient. I mean, you reduce the tillage practices, you reduce the fuel inputs into your operation, eliminate greenhouse gases. And so that's, especially with GPS technology, that's been kind of the new wave. Monitor plant populations, soil testing, you know, water monitoring is just something that will always be a part of our operation now.
This year, the Conservation District conducted several water efficiency experiments in Jules's field.
This particular field is about 155 acres total. It has a center pivot irrigation system on it that runs water out of Boulder Creek, and we normally put on about 11 to 12 inches for the season, and usually between 4 and 5/10 per application. So on a pivot this size, it takes about a day and a half to 2 days to make a revolution.
As part of the experiment, Centec installed soil moisture probes and telemetry in the field.
They had some soil probes out here and tensiometers that told us how far the water was going down after it was irrigated, when the correct time was to irrigate again. Very, very, very beneficial. And I think probably the new wave of the future.
So that's two components of what Centec provides: the probe, the telemetry, and the software. So just you can see the little dots on the probe here. That's the actual where the sensor is. 2, 6, 10, 14, 18, 22, etc. inches all the way down. So how much water you have at each level, where you've installed it, is able to find root activity, so you can tell where your roots are pulling up water, and therefore if you're over irrigating or under irrigating. Each individual probe length, like a 3-foot probe, there's a specific 3-foot auger that is slightly tapered that matches this. The reason that's important is because it works on capacitance technology, electrical signal. It has to have good contact with the soil to complete that circuit, if you will, get the right reading, which is then in turn translated into a soil moisture percentage. Telemetry into the cloud through the compact telemetry device, which essentially connects through this cable that you see here, and has a battery and a modem and an antenna. And you might have seen it when coming in. You have the antenna placed above the crop canopy so you can make sure you have the right connection. And it just sends that up into the cloud. The software is represented by what you have in your hand, and that software then takes those every 30-minute readings, graphs them accordingly, so it gives you a good idea of what's happening in your field at the depth and how your irrigation either impacts or doesn't impact your growth, the growth of your product. Therefore, have you the ability to just make better use of your water, when you need to irrigate, how much, so that you don't waste water, and of course with water go nutrients, that you don't waste fertilizer.
We then use indicators within the graph line to understand how much the plant is drinking or how much soil moisture is in the profile, and then where it is. So if we start on the left-hand side, you'll see just a little bit of variance on that line. When we see a spike up, that is an indication that we have added moisture to the profile, typically via irrigation, or every once in a while we get a lucky rainfall. Spikes are moisture added, and then the line decreasing is moisture taking out. If you continue to look right across it, you'll notice kind of that wavy pattern turning into a stair-stepping. That stair-stepping is the best indicator we can get on a probe. It indicates that the plant is drinking during the day and then resting at night. So when we see a deeper step down, that is, for whatever many reasons there may be, more moisture being taken out of the profile, such as a 105-degree, very sunny, very windy day. ET, crop consumption, that's going to skyrocket, and we're going to see a lot more moisture taken out of the profile.
You know, as precious as water is and resource is, that's something we'll see more and more all the time, that we don't have to put on any more water than necessary, but what we put on what the plant really needs and absorbs. They printed out a graph and we followed it pretty closely through the season. This corn will be harvested here in the next week or two. Like I said earlier, it's all shelled corn, grain corn. It goes to a dairy here.
The Conservation District also planted test plots of 3 different drought-tolerant corn hybrids in the field.
These were all grain hybrids, mainly maturity rate between 100 and 103 day, 104 day varieties that will mature down to be harvested for shelled corn. There were 3 different corn hybrids put in the plot, 3 different breeders.
This particular field was treated with our W12 product. Essentially what these different products are designed to do is combat drought stress, enhance water use efficiency, nutrient use efficiency. If you drive by a field, there's always a couple of plants maybe in a field full of dead corn that are surviving, thriving. What we've done is R&D wise break down those plants that are surviving in those harsh environments, figure out what is different in them biologically.
157 is a agronomic rock star. There's not many other products that can go in more places, more environments, and actually work well. As far as probably its shining star is it's designated an Aquamax, which I think is why a lot of people along the front range has planted it for so long. And Aquamax is just a subset of our products that have met drought stress testing and have yielded better than their counterparts. They're native traits that we've selected for, and they are traits that include better root systems for better aggressive silking, deeper kernel sets, the stomata control, so just different things that make the plant utilize water more efficiently.
This is a 99-day, very similar maturity. It's a drought guard, so we have an actual trait in there to help during pollination, to lower on respiration, meaning we're trying to make that plant sweat less, so we retain more water, and we use that water to help pack starches and help with finishing the final product that matters the most right in here. We do have a couple that are very tailored for water preservation, making it through drought years, making it through really, really tough situations. That would be our drought guard trait. That is a trait that we insert into plants. Like I said, it helps it just sweat less, so you retain more of that moisture inside of it. It mainly affects pollination and the reproductive cycle, so when we want to conserve resources the most, make sure we're not losing it, we're developing that ear.
We will have a weigh wagon out here when we harvest, and it will provide us the information, the data that we need to know which hybrids produce better under the types of conditions that we put them under. So I think some interesting data that will come out of this. I think drought tolerant hybrids will be a wave of the future just because of the water concerns. Talk about the Colorado River and that affects all of us here. So any way we can save water is something we got to really look into.